clap.
So this is the contest problem of 459, and we have already seen the video, but I'm seeing that most of you having doubt a lot of things. So I thought to create another video for you. So let's continue to understand in detail. Very first, understand what is trapezoid. A trapezoid or trapezium in UK and US, it is a quadrilateral four-sided polygon that has at least one pair of parallel side, right? So as you can see, this is the parallel of this, we can say, or if you take this one, it's not parallel, right? Means at least one side, means this and this is a parallel. Can we say that? But if you see this and this, these two are not parallel, because see, its angle is different. Okay, so that is why it is saying it's a four-sided polygon that has at least one pair of parallel sides. Okay, and you can pause this and you can understand what the statement is saying about the horizontal trapezoid, right? Like quadrilaterals formed by 4 points, we need 4 points to make it, right? Like that, it is also saying at least one pair of the horizontal sides, let's suppose sides with the parallel to the x-axis behavior, right? So the question what we have saying in this video, right? Let's understand. So count number of trapezoid 1. So we are given a list of 2D points on the graph, right? So this is our Cartesian plane where we have some points we have given like this we have given, as I mentioned here, right? As you can see, the dotted one is the 2D points we have given in a list of 2D graph. And so it is also saying in the definition that a horizontal trapezoid is defined as a quadrilateral 4 points that has at least one pair of horizontal side, meaning two segments that are parallel to x-axis, means same y value. Let me tell you what. So if you consider this example, right, we have points what 1 0 2 0 3 0, and like that we have other points we also have, right? So if you consider the very first one, can we say that in x-axis what we are seeing here, we have point 1 0 for this points at 0. So 1 0, then we have at 2 we have 2 0, then at 3 we have 3 0. So if you consider the first and 2 points, right, we are not taking the third point, right? So can we say that if we will take the first point and the second point, we will form this trapezoid, right? And if we'll take if we'll skip the very first point and we'll take 2 and 3 points, so it will form another trapezoid. And if we'll take this all of these 3 point 1 0 2 0 and 3 0, so then we'll form this one, right? So we can say yes, because if you are taking y-axis, right, this is our x-axis on when y is equal to 0, right, means here y is 0, right? Can we say that? And x is increasing. Okay, in that case we have 3 points we have given on these 3 points on the what do you call, on x-axis when y is equal to 0. How many trapezoid we are forming? So 1 2 and 3, and that is why output is coming 3. So let me come back to here. So now it is saying that a trapezoid, a horizontal trapezoid, means the horizontally trapezoid is defined as quadrilateral 4 points that has at least one pair of horizontal side, that we have seen already, right? Means in this axis, that is called horizontal, right? Meaning two segments that are parallel to the x-axis. So if you talk about the parallel to this axis in this trapezoid, what is parallel to the x-axis? This one and this one. Okay, and so there is two segments that are parallel to the x-axis in the same y value, right? And so we can say that we need to count all unique trapezoid that can be formed from the points where both horizontal segments are on a different y level, right? And that is why with a different y level, you can see y is different now, here is different, right? So all of these 3 cases, if you see, y value is different, and right, so we have to count all these trapezoid and we have to return how many we have formed with these points. So can we take, if points 1 0, as you have seen in the previous example, 1 0 2 0 3 0 2 2 and 3 2, when y equal to 0, right, when y equal to 0, it means we are talking about this point, right? This point here, y is equal to what? 2. Can we say that when y is equal to 2, what is happening here? Think. So here y is equal to 0, it means we are talking about y equal to 2, means we have 2 2 and 3 2. right? And that is why the other points we have 2 2 and 3 2. As you can see, after this it is coming 2 2 and 3 2 when y equal to 2. So there is 2 points 3 2 and 2 2 and 3 2, means top side horizontal we can make from here, right? So here when we have add 2, we can form this horizontal line from here, right? Similarly, when go with the point, another point here, so we'll take another horizontal points is making. So when y equal to 0 and when y equal to 2, that 2 time what you call, we form the another 2 sides, right? The top side we are making horizontal line. When we are taking all these 3, when y equal to 0, 1 0 2 0 and 3 0, means bottom sides we are taking, and this is also horizontal. So two sides are horizontally, means this top side and bottom side both are parallel to the x-axis. Okay, now we can say that we have to choose any 2 points from y equal to 2. So out of this we have to choose 2 points from y equal to 2, that is the top line, we can say that. Let's consider C to C, right? So I'll explain it later what is this C combination we are taking 2 or 2. So we are getting the pair 1. So just think that C 2 2 we are taking 1 pair, right? Similarly, if we choose 2 points from y equal to 0, will become bottom line, right? And then from the bottom line we have to choose the 2 points, right? So we'll say 3 2. We are getting how many points? We are getting 3 pairs. Let's come back to here. When we are considering y is 2 2, so 2 2 means this point we are talking about, right? And this is 3. So when we are taking 2, we can form this Cartesian plane, this axis, and similarly we can make this axis also, right? And here also, means there is 3 options we have. There are 3 options we have. Okay, that is why it is saying from 3 we have to choose 3 2, right? When we are choosing from here, right? When y equal to 0, we have 3 2. Out of 3 we will take 3, means how many pairs we can make? 3 pairs we can make. From here we can make only 1 pairs, right? Means this is 1, means between 2 and 3, how many we are making? 1. From here this plane is from 2 to 3 we have, and similarly we have 2 to 3, means when y equal to 2 we are making only 1. Can we say that we have 3? We are seeing 3 for the 3 different trapezoid. We are seeing that there is 3 we have, like no, if you see it is still there, it is not moving either this side or not moving in this side, it's still there, right? In all of 3, if you observe, this part is static, right? What we are changing? We are changing this part, this is changing, this position is changing, right? And so we can say when y equal to 2, we are getting, we have what? When y equal to 0, y equal to 2, we have only 1 pair, right? And when y equal to 0, we have how many pair? 3 pair. 3 pair, means we are getting here now we are getting here, and now we are getting from 1 to 3, means the very first is 1 to 2, then we have 2 to 3, and then we have 1 to 3, correct? Means these are the 3 pairs we have given. So if we'll multiply these pairs 1 into 3, how many pairs we will get? 3 pairs we will get. Understand? So this is the problem statement we are saying we have given. It's very critical, but if you understand with the what you call understanding, you will understand. Let's understand. We are computing the pair combinations with each horizontal line, the same y, then combining pairs across different y values to form trapezoid. So we will use what we will use, you know, C, you are choosing C number of given, and out of what we have to choose, right? Means we will use binomial coefficient. Can we see that? You know, in mathematics, when we are in the 12th route or other in the engineering, you have seen this one, right? Binomial coefficient. Means if you'll take the given is n, and after that we have to choose 2. This is our formula, n into n minus 1 by 2, right? Little changes is there, that's fine. So this is a binomial coefficient, but only for when we are picking 2 points from a group of n points on the same y coordinate. Means this is the group of points we have given. Out of that we have to choose 2 points, right? And so we can say we are picking 2 points from the group of n points on the same y coordinates. So these 2 points form one horizontal segment side of a trapezoid, we can say, right? Because if you connect the 2 points that we have seen, right, means we have these 2 2 we have and 3 2 we have. So these 2 2 and 3 2 makes one horizontal segment. Can we say that on the top one, right? You remember, right? Top one. I'm not talking about the down one, top one. So we will, when we are taking the y equal to same, right? Y equal to 2 means that time we are making one horizontal line. That is what. So then we multiply pair of two different y values to form trapezoid. So we'll use the optimized formula to count all such combinations. Can we say that? Let's understand when y is equal to 0, we have 3 points we have got. So we got the 3 points here, and similarly we'll get these 3 from the y equal to 2, we got the 2 points, the combinations. We'll put the formula that we have shown, you will get like this one, okay? So you will get the pairs, and when you will multiply it, you will get 3 into 1. Here we have to take 3 points, okay? Now, to be clear, let's understand if we'll take a combination out of n and 4 and see n to 2, right? Here you observe that we have how many combinations we have given? N. And how many points we have given? 4 points. We are thinking that in the Cartesian plane, if we'll make the trapezoid, we'll get the 4, right? 4 points we have to choose, means we have to count all 4 points combination. But no, if you'll choose 4 point combinations, right, then it will become invalid trapezoid, because the question is different. Trapezoid rule is different, but the question is here it become different, right? So the given trapezoid is invalid, so don't use this one. You have to use Cn2, right? When we have n number of groups, we have to choose 2 points, right? 2 sides we have to use on the top level and the down. When y is equal to y value, we have y equal to 0, y equal to 2, right? That case, so only 2 we have to choose, okay? So we have to use for each y level to get the horizontal side, okay? So in this case, let's suppose y level is 2, one is at 0, another is at 2. We have to use this one, not this one, okay? I hope you understand. It should be clear, right? Then combine the pairs and multiply them in the y level, how many you get, and just if we multiply, so let's understand the code here, okay? And then we'll go through, because a lot of things we have to understand today, okay? So let's suppose the given points we have is what we was given. The very first was given 1 0, right? I'll take the first example itself. Then what it was 2 0. Then we have 3 0. Can we say that? And these are the x-axis were there, and then on y-axis it was given not on like that. Okay, keep it here itself. 2 2 and 2 3 3 2 3 2 was there, right? Like this. So if this is our what you called points we have, right, given, means if we'll represent in the Cartesian plane, how we are represent this? Let's suppose when y equal to 2, when y equal to 2, there is 2 points we have given. One point here, another point was here. So this point was called 2 and 2. Can we say that? And this point we can say 3 2, like this. When y equal to 0, the point was there. It was not here. You can say little this side, okay? Here it will say 1 0, right? Then we have is 2 0, right? And then we have is 3 0. Can we say that if this is a Cartesian plane, we can say, and this is the given points we have in the array. So give me 1 second. So can we say that we have to count a group of number of points, we have to count number of points at each level, means we want to group the points by y value, right? Means if we have some y level, right, and we have to group them, all those points, by the y value. So how we are going to do that? So we'll iterate over the given points. So very first it will come 1 0, right? So from 1 0, if we'll get it from here, right, the points will come what? As a 1 and 0. So this is index 0 and this is index 1. So this is x and this is y. Can we say that? So to get the axis y, we have to do what? Points at 1, right? This is 0 index and this is 1 index. So at 1 we'll get the point y. Now what we need to do, we have a y count, right? So on the y count we'll do put as a, because this is a map integers, right? So what we will do, we'll say y count dot get or default value will do. If there is any count is there, any y value is there, we'll keep it, we'll get from there and do +1, will increase the y count. So how many y count will say come, it will say this is y count and this will your value. Let's suppose for this example we'll say the y count, so y is 0. Let's suppose very first it will come 0, means here y is 0, here y is 0, here y is 0, means for 0 we have 3 times, right? And when we go for y equal to 2, it means here we'll get here and here. When y equal to 2 means 2, how many counts is there? 2 counts is there. Can we say that? When y equal to what? 2, we are getting this value. Can we say that? And so this is the hash map we will make for y count. Understand? Then we have to go to the step 2, means we have to go for each y level and we have to calculate the number of pairs. It means very first we are grouping all the points that lie on the same horizontal line. So we got, when we have y value is 0, we are getting 3, and when y equal to 2 means we are getting 2 points, means when y is 0 we are getting 3 points, when we have 2 we are getting 2 points, means we are grouping all the points that lie on the same horizontal line, and that is why we have represented like this to make you understood. Okay, after that we have to go for the compute to the horizontal segment, means we want to compute the horizontal segment pairs per line, we can say, means for each y level we have to calculate the number of pairs. So how we can say that? Let's suppose when y is equal to 0, we got 3 points, right? So what are the 3 points are there? 1 0, 2 0, 3 0, right? Means there we can say when y equal to, for this one, when y equal to 0, can we say that we have 3 points? How many points were there? 3 points was there, right? We have seen here, right? When y equal to 0. So when y equal to 0, we got 3 points, means how many pairs we have? 3 pairs we have. Can we say that? 3 pairs. What are the pairs are there? These are the pairs we have. Understood? Right? Can we say that? So when we have 3 pairs, right? Can we say that what are those pairs? Let's suppose if we'll represent on the line, right? We have seen on that, right? So from 1 to 2, it was the very first pair was from 1 to 2, then it was from 1 to 3, and then it was 2 to 3. So these are the pairs. So can I say that we have to choose from let me see, let's suppose we'll say 3. So out of 3 we have to choose how many pairs? 2 pairs. Can we say that? So what it will come? It will come 3, right? We'll get the 3 what you call number of pairs, right? So can I say that if we'll take pair and we'll say 3 and 1, right, here for the pairs, so we'll say yes, we can take like this. When what you call, we have y equal to 0, we got 3 out of 3, we'll get 3 points here, right? Similarly, when y will check for 2, right? When y equal to 2, means how many points you will get? 2 points you will get, right? What are the points are there? Let me write here. Okay, let me write here. When y equal to 2, how many points are there? 2 points are there. So how many pairs will be there? 1 pairs, means if you represent 2 points and 1 pair. Remember, 1 pair. What are the point was there? What is the pair was there? We'll say, let's suppose 4 5. So we'll get what? C 2 C 1. No, 2 C2 2 C2 right? C to C, yeah, C to C, and we'll get what? We'll get the value 1. remember? And so we can say pair will contain 3 and 1. Now we have to take what? Total pair and total pair sum square. How we'll get this? Let's suppose how we'll get this. The total pair is 3 plus 1, because from the pair you have what? 3 and 1. So 3 plus 1 is nothing but 4. So you will get the value 4 here. And total pair sum square is what? We have to do the square. It means 3 square plus 1 square. What you will get? You will get 9 plus 1 is 10. You will get 10. Like this, you have to compute this value using this formula. Okay. Further, in the next step, we will use the formula to compute the trapezoid, right? So next, what we need to do? We have to calculate the what we call total trapezoid, right? So there is a formula that we know to get the trapezoid. What was the formula? Was trapezoid, right? Like this, you can say. Okay. So we can take EP square minus, I will tell you what is this, okay, by this. Just put the value here, you will understand. So if you want to find the total trapezoid values, can we say that nothing but a total, because we have written it a total, okay? So we'll take trapezoid value here. Let's suppose we'll say 4 into 4, and then it will become 10, that we have seen already, right? Means the pair, from the pair, how many total pair we have got? 4 pair we have got, right? 3 plus 1. So it was 3 and 1, right here. And here we got what? 3 plus 1, we have got 4. Remember? And total pair sum square, we got what? 3 square plus 1 square. We have got 10. It was 10, right? So we'll do the total pair sum square, right? And we'll do minus 10. Means the total pair sum square sum. And then we'll do divide by 2. It means we'll get what? 16 and minus 10 by 2 and nothing but 6 by 2, and we'll get 3. And number of trapezoid we will return 3. And so these things we are doing here, means we get the total like this you will get, and then you will take the what you call this value and you will find the total. Okay, but you also have to divide by 2 using a modular inverse of 2 mod, right? Mod we can say. So there will be a inverse of 2. We'll find the mod inverse and we'll find the total, and then after we'll return the this one. So let's understand what is this. So let's understand the modular function first, then we'll understand why we are using this and these things. Okay, so you know, after that we have done what? Inverse of 2 we have taken, and then on the total we have multiplied with that, and then we have taken the mod and we have find that. So mod inverse, let's suppose we have a and mod we have taken, right? Log a and mod, right? So the first modular inverse we are using from the format little theorem. Since mod is a prime, right? And so you have to use the mod inverse. So we use this format little theorem to divide under modulo, right? So the safety will be, we can say, divide by 2 and then mod whatever will come, right? The compute we have to do divide by 2, and the mod it was 10 to the power 9 plus 7, right? We can say. So we want to divide under the modulo, and for that we have to use this little format theorem. Okay, understand? To do that, internally we have to call the power function. Okay, and this is your power function. So let me again explain you to in our context why we are using this, right? So you remember in our problem we have used total, right? In above, right? I will not go again up, right? So you can just do back and you will understand. Okay, so we have we are using like this, like this. Okay, and then we have to take what? Mod I told you 10 to the power what? 9, right? And plus 7, right? This one. So when we are taking this, so we have calculated this part already, but we have not multiplied this mod 10 to the power 9 plus 7, right? Right? Because in our problem context, in trapezoid problem, we have this total, right? We are finding this total, right? But division is not directly allowed in the modular algorithm. So we need a what we call the modular division, right? If you explore a little bit, you will understand that if you do divide, right, then we have to take mod m. This was the formula, right, where what you call, we will take multiply with a and b to the power minus 1. We are doing the math, and then b, and then we are taking the mod m. Do you remember in your in our childhood, right? In I think 11th it was. So we must compute this inverse mod, where we have let's suppose call inverse and inverse mod, we can say. Give me 1 second, guys. We can say nothing but the mod inverse, right? It's good that someone has put me in the comment box that he has not understand. I like that, and I want to explain if you don't know, right? So if you have any doubt, please ping me in the comment box that you understood or not, right? So this is all our modular inverse, right, where we use b and m, right, where the modular inverse of we can say b we are using, right? Can we say that means a by b mod m? It means a into b to the power minus 1, and the mod m means what we want, mod inverse b of m, we can say, where the inverse, we are doing modular inverse of b we are doing here. Can we say that? So what is a modular inverse? Let's understand. So modular inverse is give me 1 second. Modular inverse is for any integer. Let's suppose for integer, in this case we are saying for integer a, right, its modular inverse inverse under mod is a to the power minus 1. Let me clean it, right? Can we say that for integer a, if I want to take the modular inverse of a under mod, it will become what? A minus mod m, correct? And it will become a into, let's suppose, a minus 1, and it will become what? 1 mod m. Can we say that? So this will only work if a and m are the co-prime, right? A and m are co-prime. This is little mathematically, okay? So if m is a prime, let's suppose if m is prime, right, so we can use that time, we will use what we call this Fermat theorem, and that is why, since the mod is prime, so we have to use mod means m is prime here, m is prime, then we have to use this modular formula. I hope you understand, right? So this little Fermat theorem, if mod is prime, let's suppose 10 to the power 9 plus 7, this is your mod, and sorry, this is a prime. If this is a prime, then we have to take this little Fermat theorem. I think I already have explained these things in my previous video. So if you will not watch my previous video, how you will understand these things? So you will do the comment, I don't know. So in each and every video to explain is very tough, right? But still, let me know in the comment section that you have already not know, right? Let me know, explain. You can tell me. I no worry, okay? So what I was saying, so little Fermat theorem, if the mod is what prime, then we have to use this one, right? So we can say to find the inverse of a under mod m, we have to use a to the power minus 1, we can say, and we can nothing but the mod what we call mod minus 2, let's suppose, the mod. Why? Because we have taken if m is mod. Why? Because if m is mod, m is prime, right? Sorry, m is prime. If m is prime means 10 to the power 9 plus 7, for example, in this case, then a mod minus 1 is equal to 1 mod, we can say. It means a to the power mod minus 2, and it become a to the power minus 1 mod. Understood? That is why I'm saying this one. Okay, I hope you understand. Let me know in the comment section that you understood or not, And thank you guys, thank you for watching this video. And if you have any doubt, right, please write the comment. I will not mind, because I have seen the comment, then I have created this video again. Okay, so give a thumbs up and do a subscription of this channel, so you will get more videos, right, and better videos. And also hit like the channel, right, to, also comment on the channel, so you will understand clearly, right. Thank you guys, thank you for watching this video.
Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.